Okay, so now we're going to talk about a situation where the denominators, they're not really the same, but they're opposites. So let's say you had something like 3 over x minus 7, and then you wanted to add 2 over 7 minus x. Well, they're almost the same, kind of, in a way. They're opposites. In the denominator, for the first one, you have x minus 7, in the other one you have 7 minus x. And so it's kind of like that -1 trick we talked about in another video or in the last section. But what we're going to do is we're going to go ahead and we're going to multiply the numerator by -1 and the denominator by -1. Now, you might say, well, why did you choose that one? I'd rather have x minus 7 instead of 7 minus x. So I've decided to try to make the second denominator look like the first denominator. So what's going to happen, just on this part right here, I'm going to get a -2 in the numerator, but then I'd have a -7 plus x, but then I can switch that around so that I'll still have a -2 in the numerator, but then this will be x minus 7. And now the denominators are the same. So that's the concept we're going to use. When we have one of our factors that's opposite of the other factor, we're going to multiply both the numerator and denominator by -1. All right, so here comes an example. So I have in the first denominator y squared minus 4. In the second denominator, I have 4 minus y squared. So I would rather those not be like that. Okay, so let me recopy this so that I'll have a little more room. The first rational expression, y squared minus 5y over y squared minus 4. Can't do any canceling there, so if you were thinking, oh, I want to cancel something, no, it's not factored. And then in the denominator I have on the second rational expression, I have 4 minus y squared. Okay, so what I'm going to do is I'm going to multiply by a -1 up here in the numerator and a -1, I need these parentheses, and a -1 in the denominator. Okay, first rational expression, just copy that down. And then it's still a minus sign there. That comes from right there. And then in the numerator, I'm going to have a -6y plus 6. I'm distributing that -1 I'm multiplying by. And then in the denominator, from what we did up above in that other example, those are just going to switch around. So it's going to make it y squared minus 4. Now you can write that out in 2 steps if you want to, but that's what's going to happen. Now the denominators are the same. Okay, so let me go over here. Now I can do the subtraction. Well, I have the first numerator, y squared minus 5y, minus the second numerator. And I'm going to write this out again so you can see it. All over y squared minus 4. Okay. These might take more paper than we're used to. Okay, in the numerator, y squared minus 5y, that's going to be plus 6y minus 6. Because again, you have to distribute that minus sign there. Okay, so you're multiplying by -1. Now, if you're thinking to yourself, well, didn't I just multiply by -1 and now I'm doing it again? Yeah, yep. There are ways around that, but it just gets tricky to explain and follow, and you might get confused with doing it a different way. Okay, denominator is y squared minus 4. Okay, so then in the numerator, if I simplify, I get y squared plus y minus 6 all over y squared minus 4. So it's looking good. We have a rational expression now, one rational expression, which is good. But we have to try to simplify, so we try to factor the numerator. And sometimes they factor, sometimes they don't, but this one does. And we're going to factor the denominator, which is the difference of squares. You might have been thinking that a long time ago. Okay, so now I have the numerator factored, the denominator factored. There is a like term that can cancel, so I'm going to cancel the y minus 2. And then my final answer in this case is going to be y plus 3 over y plus 2. So they're pretty fun, but they do take a little while and a little paper.